So, yesterday, are we ready? Yesterday, we looked to see what our common denominator was, and then we found it, right? We saw the pieces, we found the common denominator, and then once we knew what the common denominator was, then we wrote down what each fraction needed to have that common denominator, right? And then we stopped. We didn't want to do too much in one day and overwhelm ourselves. So today, the plan is first to figure out what the common denominator is, and then write down what each fraction needs, and then the next step is we're actually going to write down the new fractions. And then, again, we're going to stop so we don't overwhelm ourselves, because these problems kind of take a long time, and I found that students get overwhelmed pretty quickly with these. So if we look at number 1, and I break down that denominator, what do I get? Except the 6 can be broken down, right? Okay? And then how about this denominator over here?
30 times x times x times x.
So what does the common denominator need?
2 and 3, and then 4x.
How many x's does it need? 3. Why does it need 3 and not 1 and not 4? Yeah, use whichever side has the most. The right side has 3, that's the most. So our common denominator is 6x to the third. Okay, so we found that. Now we have to write down what each fraction needs. So the first fraction has a 2 and a 3. It has an x. What does it need? X squared. X squared on the top. X squared on the bottom. And now we're going a little bit further than we went yesterday. Now we're actually writing down the new fraction. So what is the first fraction now? 1x squared over 6x to the third. Okay. The second fraction has a 3 and it has the xxx. What does it need? 2. 2 on top, 2 on bottom. Okay, and then for today we're going to stop there. Yeah.
But you gotta solve it.
You have to go like if when you multiply on the top, you multiply out.
On the top, multiply it out. The bottom will typically leave in factor. And the reason that you're multiplying out the top, Alex, is because you want to be able to combine like this. When you actually add your fractions together, that's what you're doing. All right, number 2. What do I get for the first fraction?
3 times y times
3y. What do I get for the second fraction?
5 times y.
So what does the common denominator need? 3 of 5 and then 3 y's. How did Maddie know it needed 3 y's? What did she look at?
Look at the side with the most.
Yeah, the side with the most had 3, so that's what we needed. So what is our common denominator?
15y.
So the first fraction had a 3 and it had a yy. What does it need?
5y.
It's a 5y. The second fraction had a 5 and it had a yy. So what does it need?
3.
It needs a 3. And let's go ahead and write our new fractions. So, yeah, so the 5y multiplies by the whole top. That means it's distributed. So 5xy minus 10y squared, good. And on the bottom we should have 15y to the third, right? And then what's our second fraction?
15
Plus
All right, go ahead and take some time and work on 3 and 4. So 3 and 4 are very similar to 1 and 2. Go ahead and work on 3 and 4.
Actually, no. I just thought that.
I'm getting 90.
If you get 90, I'll
What are you adding on both sides? Or on the four side?
We'll see how.
Then you got comments and you scared them.
We'll see. No, because I'm
That's 4.
Or is that just going to be?
That was it.
What all are we doing in class with that?
I'm gonna keep doing more examples, and then the rest of it will be homework.
So I didn't have to
So what I would do is tonight I'd get on the website and watch the part of the video, like I'd watch this video that I'm making right now, and then get to this point and then just watch the rest of it.
Did you get 48 cubed? Yeah.
Come on.
Once you put down to 6, you cross the 6 out.
Yeah.
Okay.
Yeah, it's hard to tell me.
Was I the A
Nope.
Oh, straight off the bat.
Yep.
Sorry. I just remember I'm not gonna be here tomorrow and Friday because I'm going on the Boston trip. Is there any work that you have?
Check with me in a little bit. I can probably take it.
It's okay if you just give it to me.
Oh, I did that because 4.
I just asked her.
Okay, check your 3 and 4. Make sure you got them.
I got it.
I kind of messed up over there.
Yeah, mine's straight.
Okay. 3 and 4. We're good. Are we good?
Yes.
Okay. We're gonna move on to number 5. All right. So number 5. This one's the easy one, right? 2 times b. How about the second one? It's got a minus in it. Yeah.
Just together.
So.
It's tricky. It's difficult.
Yeah, it's one of the more difficult factoring methods, right? What's our method going to be? GCF. So go ahead and factor that one. It's a GCF.
What? That's
We would
2.
do 5 times 2
Mm-hmm.
times B.
So is the GCF the 2 or the 5?
2.
2. Okay, so
Yeah,
2
Oh,
and
you're doing it.
B. Yeah, and we have to factor it this way because of that minus in the middle.
So it'd be 5B. Minus 4.
Okay. So that means we've got a 2 that's all by itself, a B that's all by itself, and then we have that whole group. So our common denominator needs
1, 2, and B.
1, 2, and 1 B,
And then you need the group.
and then the group. Okay. So what does your first fraction need? The group. Okay. So for the first fraction, we have a 6b that's being multiplied by that group, and we have to make sure that we take the 6b and we distribute it. So 6b times 5b,
30B squared.
30b squared. And then 6b times negative 4.
Negative
24b, good. And then the bottom we're going to leave as the factored form. So I'm going to leave this as 2b multiplied by the group. And the reason I'm going to do that is because after today, once we finish these problems, we would actually add the fractions together and make them one fraction. And once we make it one fraction, we're going to have to simplify. And we always factor before we simplify. So we like the denominators to be in the factored form if they can. If you forget that and you multiply out your denominators, that's okay. You'll just have to factor them later in the problem. It's not a big deal.
What about
Now the top, we multiply out the top because we're about to have a second fraction that we have to combine like terms with the top. So the top always has to be multiplied out because we're not done with the top yet. The common denominator, however, is just going to stay. And that's why we can leave it
so you
factored.
leave the second fraction the same because nothing needs to be multiplied?
Yeah, so the second fraction already had the common denominator, and so that means we can leave it. And then again, I'm going to go ahead and write the denominator as the factored version of it. And that's just because I want to make my life easier when I do the next step. All right. Number 6, I'll do the easy one. That's just x. What do we have to do with the other one?
You could do first factor of 9.
Yep, 9 and
9
x.
And then it'd be x plus 5.
Good. And the 9, we could go ahead and we could say that that's 3 times 3. Do you agree with that?
Yeah.
Sure.
You still have to add the x in.
Yeah, we still have to have the x in there as part of the GCF. So our common denominator
3 times 3.
What do you put with it?
So our common denominator is 9x times x plus 5. So, did the first fraction need anything? No, the first fraction has the whole denominator. So we're going to call that 6x over 9x times x plus 5. I'm leaving the denominator factored. Right, Hector and Daniel? I wonder why she said our names. All right. The right fraction only has an x, so what does it need?
9.
Needs a 9
The x plus 5.
and an x plus 5. So I need a 9 and an x plus 5. I need a 9 and an x plus 5. So when we do this one, we have to be careful. Because we have a 4 times a 9. What's 4 times 9?
36.
36. So we have a 36 that's going to distribute to the parentheses. We had a 4 times 9, which is a 36. And that 36 needs to distribute to the parentheses. So 36 times x plus, and then 36 times 5 is 180. Good. And then on the bottom, we just write this part out in factored form. And so that's going to be 9x times x plus 5. All right, go ahead and start number 7. See how far you can get on number 7.
So you're always gonna have the same two denominators.
Yep, your denominator should always be the same because that was what your goal was, to get them to be common. Yeah. So if they're not the same, it means you missed something.
Oh, yeah. Did you? Oh, you did? You told me about it. Wait. So just, is that just it, right? Because like, yeah. Dude, this is like,
I did parentheses too.
Yeah. So what type of factoring did you do?
I just like took it.
Yeah, so you did GCF.
Oh.
So take out a GCF of 2,
so,
and then n minus 4.
So how do you know when it's different to squares?
If you've got perfect squares in there. Like if it said like n squared, that would be a perfect square because it's squared.
Oh, okay.
If it said 16, 36, 81, 100, 121, 4, 1, all those nice perfect square numbers.
Okay.
So what's our common denominator?
2.
We need a 2. We need an n.
Then you need the group, right?
And then we need the group. Go ahead and see if you can figure out what each fraction needs. So the first one had the 2 and it had the group. What does it need? It's an n. So it was n squared plus 3n. And then I'm leaving the bottom in the factored form. So I'm going to take these two and put them in the front. And then leave the n minus 4. What did the second fraction need?
The group.
The n minus 4.
The n minus 4.
Wait, if you do that, what did I be next one?
It's 5.
I didn't multiply that.
It's 5 n minus 2.
Yeah.
Turn it around.
You can turn around, Chloe, but then I'll put you back. You're not going back to your group. You were expelled from the group for today. Alright. So the second fraction is
5n minus
5n minus 20. And then the bottom is
2n, and then we need.
Alright, for number 8, I'll do the easy one. What type of factoring is this one? Difference of squares. Okay, don't say it out loud, just go ahead and write it down. 2 sets of parentheses, one with a plus, one with a minus.
It's 2.
She said don't say that.
I didn't hear her.
It's okay, I didn't hear your answer. So what did we get?
2
P plus 2, P minus 2. So what's the common denominator?
P minus 2. Oh, P plus 2.
Yeah, so each of them had a plus 2, so the common denominator definitely has one of those. And then the left fraction had a P minus 2, so we also need that. So does the first fraction need anything? No, it's got both of them, it's good. And I'm going to go ahead and write it with that factored denominator because I'm going to be lazy in the future. So what does the second fraction need? P minus 2. So what's on the top of the second fraction?
4p minus 2.
Make sure you distribute, yeah. Make sure you distribute the 4 to the 2. Yeah. All right. And if you flip it over, you're just going to find more of the same thing. So the plan is you've got 25 minutes. Hopefully you can get most of this done in 25 minutes, but the back of the sheet is your homework. Okay? 25 minutes, and then whatever you don't finish, you take home. We got it? Yeah. This is what we're doing. The whole back.